Thanks, Raquel. So I'm Ryan Henry. I'm going to talk a bit today about some research that I've been doing in private information retrieval. So just to start, let's briefly review the landscape of internet technologies. So on the one side, we have technologies that were carefully engineered to protect the privacy of the users and the various stakeholders that interact with this technology. And on the other side, we have technologies that are actually useful. And I would argue that this intersection here consists of all the technologies that are unambiguously societally desirable. The problem, of course, is that that intersection is very tiny. So my research tries to move these two circles closer together, the ultimate goal being completely overlapped so that more of the technology we use is actually respectful of our privacy. And one aspect of this that I've been thinking about a lot recently is information retrieval. So this is one of the most common things that happens when you use a computer. For example, this morning, if you tried to look up the program for Research Horizons, you might have launched your web browser, went to Google, and typed in Research Horizons. And so when you ask Google for Research Horizons and it gives you the responses, this is an example of information retrieval. But before that actually happened, your browser behind the scenes went to a DNS server and said, hey, how do I get to Google? And the DNS server said, here's the IP address for Google. That's another example of information retrieval. And before that even happened, when you clicked on the browser icon, behind the scenes, your operating system was doing several different information retrieval requests to get the binaries for the browser and so on and so forth. And so now the question is, of course, this all works great, this is useful, but is it private? And it turns out that it's often not private, particularly when we're on the internet. So when you make requests, information retrieval requests on the internet, often this information goes to various different parties. Some of these parties we can identify. There's companies that are trying to profit off of knowledge about you. There's spies and identity thieves and various government agencies. And then all of these silhouettes here are various other parties that are probably impossible to identify. But cryptography does have, at least in theory, a nice solution to this problem. There's this thing called private information retrieval, which is basically a way for you to fetch information from a remote database server without the database actually learning what was requested or what was returned to the user. And so in theory, this solves a very large number of privacy problems that arise when we try to use the internet. But in practice, there are some challenges that so far have prevented PIR from being used for anything. And so the big challenges are very high cost for the service provider. Whoever's hosting this database has to invest in some serious hardware. And even if they do that, the performance is extremely poor in comparison to non-private information retrieval. The existing approaches have low expressiveness. By this I mean it's very hard to build applications that actually use this sort of information retrieval as opposed to the non-private forms that we traditionally use. And it can make some unrealistic assumptions, which mean that, well, it looks good on paper. When you try to use it in practice, the privacy guarantees we had might not actually hold. So I've been thinking about something called batch coding and how that can help improve the situation here. So originally, batch coding was designed to address the first two, the high cost and performance, and bring things closer to the realm of practicality. In some recent work, I've started to observe that you can actually leverage the same ideas to not only improve on the cost and performance of the protocols, but to help out with these other two. And so I'm hoping that if I continue this line of work, we'll eventually actually move that X all the way into the actually useful box and be able to protect real people's privacy. So why might you want to do this? So there's some pretty compelling apps that I can already kind of build. I'm getting very close to being able to actually get these things into deployment, which is quite exciting, at least to me. So one thing is a location-based service that doesn't have to reveal your location. So think Google Maps. You can ask what coffee shops are near me without telling Google where you are all the time. A Twitter-like system that lets you follow people without revealing to Twitter who your associates are. Could build something like an Amazon Kindle store that doesn't necessarily reveal to Amazon which books you're downloading or which videos you're downloading. Could build cloud storage systems that don't reveal to the cloud provider what your access patterns are, which files you're accessing at which times. Can build DNS servers that let you ask what Google's address is without telling the DNS server every website you visit. Can build the blockchain queries for cryptocurrencies like Bitcoin that don't reveal your wallets and your transactions to various strangers on the internet, could build targeted advertising systems that don't facilitate profiling and discrimination, and we can build surveillance systems that let the government protect us without violating our civil liberties. And if anybody has any other ideas on where we might want to use this stuff, please come find me or send me an email. Thanks.